All right, today we're going to look at how you can graph inequalities. So we've already been solving inequalities, and so now we're going to look and see how they would be graphed on a number line. So in our previous lesson, we've looked and seen how we can solve them, and then what are some possible solutions. So now we're going to put those things together and go ahead and graph. So the first thing we want to look at is if you're used to a number line, a horizontal number line from left to right, we usually have 0, and 0 doesn't necessarily have to be in the middle, but a lot of people like to do that. And we can do groups of 1, groups of 2, groups of 3. It doesn't really matter, but I'm just going to put groups of 1 here. Now remember, when we graph, our negatives are opposite than positives, so the further you are, normally when we count 1, 2, 3, 4, this way it's going to go backwards, -1, -2, -3, and -4. Think about owing money. The further you are from 0, the more money that you owe. So important note that I want you guys to remember is that left is less. The further you are to the left on the number line, does not matter where you are, you're going to be less than any number to the right. So for example, -2 is less than +3 because it's further to the left. Okay? The other thing that a lot of students don't really realize is if you actually look, this is the less than sign, right here. See how it's pointing like that? That's pointing just like that. And this over here, like that, is the greater than sign. So that's one way you can kind of help yourself as well, greater than. Okay? So if you are comparing -4 to +3, 3 is greater than -4, or -4 is less than +3. So just something to think about. Okay, so now what we're going to look at is here your greater than sign, less than, greater than, or equal to. So if it's underlined, it means it includes that number you're comparing. Less than or equal to, so again, if it's underlined. And another way you can think about that is it's literally half of the equal sign. Okay, so that's where it's underlined. So if something is greater than, we are going to use an open circle because it does not include that number. Okay, if it's a closed circle, it means it does include that number. So when we have verbal phrases in a word problem, these are some of those key phrases for greater than, more than, larger than, or above. For less than, we have key phrases less than, fewer than, smaller than, or under. For greater than or equal to, no less than, at least, and minimum. This is the one that confuses a lot of students because they think of the word least and they want to say this one. But if it's at least, it means it's could be the amount or more. For example, if you said you had to answer at least 5 out of the 8 questions, you could answer all 8, but the minimum that you have to do is 5. Okay? Then a closed circle for less than or equal to means no more than, so it's up to that amount. So it's going to be that amount or less. At most, again, that one confuses people because they think most and they want to use the greater than. But at most means it's no more than that amount. Maximum and up to. So for example, if you were to go ride a ride and they said at most the maximum height, anything like that, you could be that height or underneath that height. Okay? So use this as a reference when we are solving. And again, we're going to say that the open circle does not include the number. So the open circle does not include the number that we're comparing. So for example, if it was x is greater than 3, you would start at 3, but any number greater than that would work. So these are kind of like our starting points as well. That's how I like to think about it. So the closed circle, just draw my arrow here to help you guys out. The closed circle does include the number. And this will make more sense when I do a couple practice problems with you to graph. Okay, so the open circle does not include the number, the closed circle does include the number. Okay, So let's go ahead and look at a couple of examples as well to help you out. And the other way that I was going to say before we move on, the silly way that I remember it, extra ink to underline means extra ink to color in that circle. Okay? No extra ink to underline means there's no extra ink to color it in. Okay? So basically when we were looking at these, when we're comparing the numbers, it's going to be our starting point. So let's look at a few of these to help us out. So I'm going to do 3 of them with you before you have some independent practice. So if they don't give you the numbers on a number line, you can draw one for yourself. They don't always have to be in groups of 1. You can kind of change it up, groups of 2, groups of 4, however you need to do it. So again, let's look and see how we can do this. If this says x is less than or equal to -2. So in our previous assignment, we were kind of saying, okay, check all that apply or see which ones could work. But with this, we're just going to graph it. So the first thing I want y'all to know, the number that they give you is your starting point. Okay, so we're going to go to the number -2. Sorry, the camera's adjusting. Give it a minute. All right, so -2 is my starting point. So I'm going to put a circle there. If I said x is less than or equal to -2, the or equal to, can use right there, less than or equal to, that means it's going to be a closed circle because it does include the number. So I'm going to color that in. Because -2 is not less than -2, but it's that underlined part, the or equal to. Again, the silly way that I remember it is extra ink to underline, extra ink to color it in. So we want all the numbers that are less than. Well, here's another trick. If and only if your variable is on the left, you can look right there, and that's pointing to the way that you're going. It's pointing to this less than sign. -3 is less than -2. -4 is less than -2. -5, -6, and so on. I made this dot bigger because that's our starting point. So then you would just connect the dots. It's going to go on and on forever. Okay, so any number between -2 and infinity going to the left is less than or equal to that -2. All right, now we have another one. I'll do it a different color so we can see it. X is greater than 4. So again, this number right here is your starting point. So 4, I'm going to put a circle right there. Now I have to decide if it's closed or open circle. So X is greater than 4. So just the greater than sign is going to be an open circle because it's not including that number. For example, if I put the number 4 here, 4 is not greater than 4. So that's why it's a non-solution, means open circle. But that's going to be my starting point. So the greater than, here again, if your variable's on the left, it's pointing right there. It says go to that greater than sign. And sure enough, 5 is greater than 4. 6 is greater than 4. Even this number right here, very, very small, 4.0001, 4.5, 5.2, 6.1. All of those numbers are true solutions, so we're going to shade them like that. Okay, so open circle, starting at 4, and everything to the right. Okay, so if your variable is on the left, use that to kind of help guide you to where you're going to do that. Okay, so if your variable wasn't on the left, we'll show you later on how you can kind of rewrite your inequality. All right, so now we're going to put it together. We've solved two-step inequalities. Well, now we're going to go ahead and solve and now graph. So just in case you forgot, the first thing we did was we circle our inequality sign, and then we separate. So what I do to one side of the equation, I'm going to do to the other. Now with this, we solve them like equations, but there's one extra step. We have to see if we're going to keep the greater than or equal to sign or reverse it to less than or equal to. So we look at the coefficient. Our 9 is our coefficient working with that variable. It's positive, and so since it's positive, I bring the inequality sign down. It stays the same. Now we solve like normal. So get rid of the constant of that -8 or that -8 with adding 8 to both sides. Then we got 9x on the left. 82 combined with 8 is 90. The 9 in front of x means multiply, so we're doing its inverse operation. The opposite of multiply is divide. Remember, you divide by the same number you were multiplying by. So x is greater than or equal to 90 divided by 9 is 10. So you have to first solve the inequality so we know what we're comparing. The reason we're getting this by itself, the x by itself, is so we can graph it. So which of these numbers could we substitute into the inequality to make it true? So here again, that 10 is my starting point, whatever number they give you. Only when it's the x by itself. So 82 is not the starting point because x was not by itself. So we're going to go to the number 10. Well, this is 0. This is 20. So right in the middle is 10. Extra ink to underline, extra ink to color it in, because 10 is not greater than 10, but it's that second part, that or equal to. Okay? And every number that is greater than 10, well, negative 60, negative 40, negative 20, and 0, those are all smaller because remember, left is less. Those are smaller numbers. So all the numbers that are greater than, well, again, my variable's on the left. There's my greater than sign, so I can just draw a line right there. Because 20, 30, 40, 50, and 60 are all values that are greater than 10.